So in this video, you'll be understanding the concept related to current divider, how do we find power associated with the resistance, concept related to Ohm's law, and analyzing the circuit, analyzing the statement and to represent equivalent circuit diagram and then to find R equivalent. I am Mohan BS, working as assistant professor in Department of EEE SJBIT. So let's see here. So here they've given us the circuit. So through this circuit, one has to write down the circuit diagram, and from there we have to analyze. So if you have not interpreted the right question, if not interpreted in the right way, then the circuit diagram would be wrong. And as the circuit diagram is wrong, the entire steps would be wrong. So one branch of an electric circuit consists of two resistances, that is 2 and 4 ohm respectively, and they are connected in parallel. So we have 2 and 4 ohms which are connected in parallel. Another branch consisting of 3 resistance. So we have another branch, right, which are having 3 resistance respectively as 1, 3 and 5. And how are these 3 connected? These 3 are also parallel. And until now they have not told how are these 2 branches connected. However, in the next sentence they say that these 2 branches are connected in series. Okay, next. Then they say a resistance of 7 ohm is connected in parallel with this combination. So this combination means from this end to this end. To this combination we have 7 ohms. And how is it connected? Parallel. Right. So this is your circuit diagram. And they say the first thing that we have to find is find the total equivalent resistance across this combinational circuit. So it is very easy because they have only suggested that 2 ohms and 4 ohms are connected in parallel. Then 1, 3, 5 they are connected in parallel. So then these 2 are connected in series, and to this combination 7 ohm is connected in parallel. So you can see the hint is already there in the question. So the main crux of this problem is you should know how to write the circuit. Now, as they have told, 2 and 4 are in parallel. So generally how do we solve? I have taught you. So 2 inverse plus 4 inverse, the whole inverse, we get 1.33. So let us represent it as it is. And then 1 inverse plus 3 inverse plus 5 inverse, the whole inverse is equal to 0.652. Now generally this point is what students they tend to miss, the whole inverse. So how are these 2 connected? Series. And to this combination we have 7 ohms in parallel, right? So add these 2, we get 1.89, and this and the 7 ohms they are in series. So R equivalent is 1.546 ohms. So we have just found the total equivalent circuit. So let's see what is the next question. The next in the statement they say, if a 10 volt battery with an internal resistance of 2 ohm is connected across the circuit. So across means parallel. So across the circuit we have 10 ohms and 0.2 ohms, right? So here is 10 ohms and here is 0.2 ohms. It is connected across the circuit. So why I have taken positive here only? Can't I take it here? Yes, you can take here also. It's just an assumption. Okay. Now we have to find the total current. Now here we have already found what is the R equivalent for this combination circuit which has been highlighted. So for this we have already found what is the R equivalent, and we had got that as 1.546 ohms. So I'm just replacing that, and now it's easy to find the total current. Just apply KVL, and what do we mark here? We mark here positive and negative, here positive and negative. So as you apply KVL in this direction that we have assumed, so we get 1.546i plus 0.2i minus 10 is equal to 0, or we get I as 5.727 amperes. And now we'll see the application of current divider to find current through 4 ohms and current through 5, and then we'll find power associated with 5 ohms. So now the total current as we have found is 5.727. So let's understand the current divider. So now this is circuit, just a derivation. So we have 3 branches where we know what is the current that is appearing, the current source, and one has to find what is I1 and what is I2. Now, so we know that these 2 R1 and R2 are parallel, their voltage remains the same, right? That is, we have positive at the top, negative at the bottom. Now, so these are the formulas. Let us see how do we derive. Now, so why positive at the top, why not at the bottom? So why we have written here positive and why not negative? So for that we have seen a video. You can see a video under KVL, right? So if we assume the current going right, we'll have a positive drop and negative drop here. That's how we mark the polarity across the resistance. So why current is going down here? Because according to the source, the current is moving upwards. It moves right and comes downwards. Now we know that V1 is voltage across R1, V2 is voltage across R2, which is nothing but I1 into R1 and I2 into R2. Thus, we know that V1 is equal to V2 is equal to V in parallel circuit. Thus, we know I1 R1 is equal to I2 R1. We call that as equation 1. Then I'll try to represent what is I2. So just take this R2 on the other side, that's the denominator, and equate that as equation 2. Now, by KCL at point 1. So where is point 1? At this junction. So at this junction, when I apply KCL, I is entering, I1 and I2 are leaving. Now I substitute the value of I2 in equation 3. As I do that, I get I is equal to I1 plus I1 R1 into divided by R2. So I'll just segregate for I1, simplify, and then I'll write the equation for I1 is what we need. So assuming that we know what is the main current I. So then I'll write, or I'm getting I1 as shifting R2 on the other side and shifting R2 and R1 to the denominator. We get I1 is equal to I R2 by R2 plus R1 or R1 plus R2. So you can see this equation is as same as this equation. So let us see now. So when you want to find the branch current, where we have 3 branches, I repeat, where we have 3 branches, current in one branch is known, current in other 2 branches are not known. Main current, so which is the main current? I is the main current. Opposite resistance. So now for I1, which branch is opposite and where we do not know the current? That is R2. We do not take R because we know current flowing through this. What if I have a resistance called R4? How will my equation I1 change? So then I'll have my equation I1 as main current I into opposite resistance, that is R2 plus R4 whole divided by, now see sum of the resistances. So we'll have R1 plus R2 plus R4. So we'll write R1 plus R2 plus R4 because we know what is the current flowing through R. So nowhere this resistance will be in picture. Either the resistance is here or here or here or here. It has no effect. Similarly, what is for I2? So I2 main current is I, opposite resistance. So for I2 opposite resistance is R1 divided by sum of the resistance R1 plus R2. Now let us see if we had R4 here, how different it would be for I2. I2 is main current into opposite resistance divided by the sum of the resistance R1 plus R2 plus R4. So this is how one has to apply current divider. So here I have just changed for you to introspect what would be equation for I1 and what would be equation for I2 for this given circuit. So here you will not use this R. So pause the video, write down, and then you can verify. So I assume that you have paused and you have written the equation. So let's verify them. So main current I, for I1 the opposite resistance is R2, sum of the 3 resistances. Now for I2 main current is I, opposite resistance is R1 plus R3 divided by R1 plus R2 plus R3. I'm not deriving this. I'll do the derivation part for you. Anyway, it will not be asked in exam. But just in case if 3 branches are parallel, you can just make a note. How do we write the equation for I1, I2 and I3? Now let's find current through 4 ohm. So now we know the main current is 1.57. We know main current as 5.727 amperes. It enters at this junction and then it splits into 2 currents. I call it as I1 and I2. Now how do we find I1 and I2? So for that we need to have a simple circuit. So what I'll do, we know the 2 and 4 are in parallel, 1, 3 and 5 are in parallel. So I'll try to represent that. So here again further we need to find I4. Once we find I4, that will be the current through 4. Now we'll have current I4 and we'll have some current I3, and then at the end it comes at this junction as the same current I. And again, to find power consumed through 5, we'll find what is the current flowing through this branch. And here we'll have the same current I1 and then I2, it comes out as 5.727 amperes. So 1, 3 and 5 are parallel, 0.652 we have done earlier. 2, 4, they are again parallel, we have seen last time, we got the answer as 1.333 ohms. So now, we'll find what are these two currents by current divider. So I want you to pause the video, write the equation for I1. As of now, we are not interested in I2 because we need to find current through 4 ohms. So once we find the current entering here, again apply current divider, find the current through 4 ohms. Okay, so I hope you have written the equation correctly. So I1 is equal to 5 main current into opposite resistance 7 ohms divided by sum of the resistances, that is 1.33, 0.652 and 7 ohms. Now I2, I have done that, you can make a note of it, however it's not required. You can apply current divider to find I2, or by KCL also we can find out what is the value for I2. Okay, now, so we have got I1, let us find what is current through 4 ohms. Right, so again the current would split. I want you to pause the video, apply what is the current flowing through 4 ohms. So I4 is equal to I1. I1 is the main current for 2 and 4 ohms into opposite resistance 2 divided by sum of the resistance 2 and 4, we get 1.488 amperes. And now here we get back the same I1 current. Let us find the power consumed in 5 ohms. So 0.652, how did we get? Because we had 1, 3 and 5 in parallel. Now let us find current through 5 ohms. I hope you have remembered that we have different equations for current divider when we have 2 branches in parallel and we have 3 branches in parallel. So according to that, I5 is equal to I1 into 1 into 3 divided by 5 into 3 plus 5 into 1 plus 3 into 1, we get 0.582. Or do, if you want to use only for 2 branches, convert 1 and 3 as parallel, then you'll have 2 branches, then you can apply 2 branches circuit. For example, 1 and 3 parallel, we get the answer as 0.75. Then we have 5 ohms here. We have main current I1 and we have I5. So I can write I5 as main current into opposite resistance divided by the sum of the resistances. So I'll get the same answer as this. You can try doing this also. Let's find power. So power formula, we know I square into R. So current, what is the current flowing through 5 ohms? That is I5. So I5 square into 5, we get 1.694 watts. So thank you for watching the video. Please do subscribe our channel to enhance your knowledge further.